Okay, friends, what we're going to do is we're going to throw back to the first exam and look at some math we did there and see how to apply it with a couple edits to what we're trying to do now. Back then, I was trying to approximate my success rate at Wordle. If I remember correctly, I think I had a 94% success rate based on a sample. And then I had to put a plus or minus around that because it was only a sample and I was trying to figure out my entire population parameter was. This was the calculation you saw me calculate back then. And the questions you might have had at that point may have been, well, what's that 2 doing there? Well, now we can answer that based on the work we've done with the bell curve. You remember that back in the day, 2 standard deviations represented about 95% of the data. And that's exactly why the interval we formed was called a 95% confidence interval. Because when you use a z-score of 2, let me find some chalk here. When you use a z-score of 2 or negative 2, that's the same as going out 2 standard deviations, which traps 95% of the data, starting at 0, which is the average. What we want to do now is a similar calculation, but we want to address the claim that the journalism students are doing worse. Worse. Not differently, but worse. So we're trying to see, with 95% confidence, still, like we did back here, we want to see if their scores are low enough to be outside of the confidence interval for the same exact reason we used confidence intervals back on exam 1. But the difference is we only want to flag them if they fall too far left, which is worse. We're not interested in seeing if they're better because we know percentage-wise they're not better. It's 71% versus whatever the school's average was. But we want to see, is that 71.4% too far to the left? So what we need to do is we need to recreate this interval, but we need to make it one-sided, which means it's got a hard left side, but the right side goes all the way into the tail. Now, the kicker is we also want to continually trap 95% on the curve, which means we want to fill in this last little bit up here. Well, I can't just do that now and use negative 2 as my cutoff. Actually, that negative 2 isn't even really negative 2. It's negative 1.96, as you remember. I'm going to have to move that negative 2 this way a little bit. In other words, where's my eraser? Whatever area I just added there, I'm going to have to remove that area here and figure out what new z-score traps 95% of the area to the right. And that's what you're going to do right now.